Hello students, welcome to section 12.7, Similarity of Solid Figures. Solids that have the same shape but are different in size are said to be similar. We did talk about similarity with triangles, and we also did some similarity of different polygons beyond triangles in the past. Today we're going to be taking a look at obviously solids. You can determine if two solids are similar by comparing the ratios or scale factors of corresponding linear measurements. The scale factor is 1 to 1, then the solids are congruent. So in this first depiction, we see two rectangular prisms. We've got 3 by 4 by 2. And then if you scale it up by a factor of 3, in other words, 3 times 3 is 9, 4 times 3 is 12, 2 times 3 is 6. This rectangular prism, of course, is larger. I would relate the two by a scale factor of if you divide 3 by 9, actually, that's as easy as it has been in the past, or 4 by 12, 2 by 6. 3/9, of course, is 1/3. So the scale factor would be 1 to 3. You go in the other direction, comparing the large prism to the small prism, it'd be 9 over 3, or 12 over 4, or 6 over 2, which is a ratio of 3 to 1. These two, next to that, you can see here we've got two, I would say, triangular prisms because the bases are triangles. As it turns out, all their respective dimensions are congruent or are the same technically. So these are congruent triangular prisms. These two, and then the far right side here, these are not similar because if you were to do the ratio of 8 to 4 and then 12 to 12, well, those ratios are not the same. 8 over 4 is 2, while 12 over 12 is 1. Moving on. Determine if each pair of solids is similar, congruent, or neither. I will include scale factor on one of these questions as well as your homework for tonight. So the first problem here, you've got a rectangular pyramid or just pyramid. Does have a rectangular base though, of course. Turns out you can rewrite the values 10 and 5 as 10/5. 6 and 3 is 6/3, and 8 and 4 is 8/4. Well, those are corresponding parts, if you recall from prior sections, so we can write them in that manner. 10/5, 6/3, and 8/4, in fact, are the same ratio, 2 over 1 or 2 to 1. So yes, the scale factor is 2 to 1, comparing the left to the right pyramid, or vice versa, if you compare the right to the left pyramid. 1 to 2 would be acceptable for a scale factor as well. So similar is the resulting answer to this problem. So we'll use scale factor, like I said, in the future on homework for tonight. Number 2, neither. As you guys can hopefully remember, we compare the ratios 1 to 4. 1 is to 4 is not the same as 5 is to 12, nor as 7 is to 28. Well, actually, 7 over 28, correction on that, that actually does, in fact, simplify. 7/28, of course, is 1/4. Nonetheless, 5 to 12 or 5/12 is not equal to those other two. So no, neither. They're not similar. Number 3, the answer here is congruent. Again, if you were to compare and relate all the corresponding parts or sides linearly, 2 is to 2, 7 is to 7, 2 is to 2, 6 is to 6. So all the corresponding parts actually are the same. So these are congruent solids. Number 4, these apparently are similar. The reason I would argue, if you do 6 over 2, which is 3, and you do 21 over 7, that's also 3. So the ratio or scale factor, and I'll just say it here, will be simply 6/2 or 3 over 1, 21/7, also 3 over 1. Compare the small cylinder to the large cylinder, the ratio would be 1 over 3 or 1 to 3. Number 5, neither. This is a cone. Well, this is a cylinder, so you can't relate those in any way, shape, or form as being similar or congruent. And last but not least, number 6, you have, let's see, you have a rectangular prism here with sides of 4 by 5 by 8. Now, the one on the right here is oriented a little bit differently. 4 is on the bottom, while 5 is running vertically, and 8, similarly, I guess you could say, is the same as it is here. The orientation shouldn't really mean a whole lot in terms of differentiation. These are exactly a representation of congruent solids. So that concludes today's notes.